All right, in this section, 6.3, we are looking at simplifying radical expressions. We're taking a look at simplifying radical expressions. So we start off by just talking about the product rule, specifically for radicals. What this product rule tells us is that if we have two radicals, right, let's just say the index is k, the radicand is a, right, and then we have another radical, right, once again the index is still the same, it's k, but this time the radicand is b. If we multiply two radicals, then the answer is the index written again, and all we do is multiply the radicands. All right, so this is the product rule for radicals. So let's take a look at some examples. How about you're asked to multiply the square root of 3 times the square root of 5. Once again, if we see nothing in the inside, it implies it's a 2. They're both the same. We just rewrite it, and we can do 3 times 5 in the inside, and we get the square root of 15. Second example, how about the square root of 5a times the square root of 2b. Once again, these radicals are next to each other. No operation in between them, so this implies multiplication. They are both square roots, so we can rewrite the square root one time, multiply the inside, put them both in the inside of one square root, multiply them, and we get the square root of 10ab. We could have written the letters the other way. It would have been fine as well. How about example C? We got the third root of 4 times the third root of 5. We can see that our indexes here are both 3. We're multiplying, so we can rewrite this. Now we got a third root, and we just multiply 4 times 5. So it's the third root of 20. And one last example, D. How about the fourth root of y over 5 times the fourth root of 7 over x? Once again, we're multiplying two radicals. They both have an index of 4, which is the same. So we can go ahead and write that one time. And all we're doing is y over 5 times 7 over x, which gives us the fourth root of 7y over 5x. Remember, we just multiply the numerators, multiply the denominators. Okay, let's take a look at our next example. How about example E? We have the square root of 5x times the fourth root of 3y. So we cannot multiply them because indexes are different, but let's go ahead and convert to exponential form and see what happens. And that was covered in 6.2, right? In 6.2, we learned that we can go from our radicand to exponential. And we learned that if there's nothing in the inside there, it really just means that it's a 2. So this is really 2. Open parentheses, our 2 open square root symbol. How about 5x in parentheses to the power of 1? And we do the same thing over here. Right? We're just going to rewrite it. So then that way we know what the numerator is and the denominator in fraction form. So we're going to go from this to that, right? We're going from that to that. So this would be 5x in parentheses to the power of 1 over 2 times, open parentheses, 3y to the power of 1 over 4. Oh, what we can do now is we can try to make them to have the same denominator. Let's have the exponents have the same denominator. Right, so our LCD there is 4. Right, which means we'd be multiplying this by 2 and that by 2. So we get 5x to the power of 2 over 4. And then this 3y to the power of 1 over 4 stays the same. And from here, what we can do is we can use our power rule. Of exponents that tells us open parentheses ab close parentheses to the power of n is the same thing like saying a to the power of n, b to the power of n. Right, we can see that both of these have a 4 in the bottom, right? So we can say pull out a 1 over 4, right? And this just is 3y because 3y times 1 over 4 is this. And now we have to do with this 5x is give it an exponent of 2. Because once again, if we were to multiply 2 times 1 over 4, it's 2 over 4. Right? Which is what that is. And if we were to multiply here, that's like a 1 times 1 over 4. That's 1 over 4. And that's what this one is. Okay, so what can we do here now? We can actually do this to the power of 2, right? So 5 to the power of 2, that's 25. This to the power of 2 is x squared, right? Times 3y, take it to the power of 1 over 4. We can actually multiply 25 and 3, so that gives you 75. That's x squared to the power of y. And this to the power of 1 over 4. And now we can write it as a radical, right? 4 comes on the outside. The inside is 75x to the power of 2y. So a little different than our first 4 examples in A, B, C, D. Once again, what we notice with A, both the same, we can multiply them. B, both the same, we can multiply them. Right? They're the same, we can multiply them. C, they're both the same, so we can multiply them. Even D, they're both the same, we can multiply them. But with E, this is a special case. When they're different, right? When they're different, you have to do a little bit of work there. Okay, so example E is a nice example, one that I would encourage you to practice a little bit. Now let's go ahead and take a look at simplifying radicals. All right, so let's take a look at simplifying radicals. And when we're simplifying radicals, we're looking at something like, how about the square root of 4? We know the square root of 4 equals 2, right? How about the square root of 25? We know the square root of 25 equals 5. All right. And even the square root of 81. We know the square root of 81 equals 9. All right. Once again, because We know 2 times 2 gives us 4. Right? We know 5 times 5 gives us 25. It's multiplication symbols. And we know 9 times 9 equals 81. But what we're going to do is we're going to try to simplify this by factoring, right? Or using the factor tree. All right, I want to take a look at specific square root of 81. All right, if we were to break up 81, 81 is 9 times 9. We break up 9 to 3 times 3, and we break up this 9 to 3 times 3. So these are our prime numbers. Square root of 81 really means that we have an index of 2, and I'm going to show all my prime numbers. I got all of these 3s. 1, 3, 3. This index tells you how to group. So we're going to group in 2s. That's going to come out. And that's going to come out. And we multiply those numbers, and 3 times 3 gives us an answer of 9. Right, so we can always simplify by factoring. All right, let's take a look at another example. Let's call this A. How about example B? How about the square root of 50? Right, we break up 50, and this is what? How about 5 times 10? We break up 10 to be what? 5 times 2. These are our prime numbers, so this is really 2 square root. We have a 5, we have a 5, and we have a 2. We're pulling once again in groups of 2s. We see 2 5s. That comes out. And what's left on the inside is a 2. So that's how we simplify square root of 50. How about example C? Third root of 32. Let's break up our 32. How about 8 times 4? Our 4 is 2 and 2, which are prime. Our 8 is a 2 and a 4. 2 is prime, and our 4 is 2 and a 2. A whole bunch of 2s. So now we got third root. How many 2s do we have? 1, 2, 3, 4, 5 of them. 2, 3, 4. And you're pulling in groups of 3s. So you got 3 2s. That comes out. You rewrite your third root, and you're left with 2 times 2, which is a 4. So a nice example there. How about one more example, D? How about this time the fourth root of 48? We can break up our 48 to what? How about 16 times 3? That's prime. We break up 16 to 4 times 4. These 4s break up to 2 times 2. And so does that one, 2 times 2. So now we rewrite this. This is the fourth root. We have, looks like 1, 2, 3, 4 2s. 1, 2, 3, 4 2s, and a 3. This time we're pulling in groups of 4s. So those come out. 2, we have our fourth root, and we write our 3. There we go. So this starts off our 6.3, and I'll continue here short.